All right, without further ado, to keep things rolling, Michael Ripperger, he's our ROS Industrial Tech Lead. He's been at SwRI now for about 9 years. So Michael started here as a mechanical engineer, kind of has transitioned to software, has worked on a number of big programs. His bio is in here. I won't read it word for word, but he's also has been involved in training, key player in SwRI, a big contributor on the A5 program. Michael, the floor is yours.
All right, thanks, Matt. Yeah, thanks for coming out, everybody. And I want to spend my time today talking a little bit about sort of our tech vision for providing open source solutions for industry. So when I first sort of got involved with the ROS Industrial Consortium, probably 6 or 7 years ago, there's kind of a lot of talk at the time, I think, about making like the ROS Industrial Killer app, right? The thing that you could just download and we could all use to kind of do like scan and plan type things. And so that's, I think, where we had like really focused a lot of our effort was trying to make that application. Right? So we spun up this focused technical project around blending. We had a couple of milestones that resulted in the Godel project, if you guys are familiar with that. And so that was sort of our first iteration of scan and plan. And so that project was great, right? We were able to do mesh reconstruction from point cloud data. We were able to generate tool paths and generate motion plans for grinding, execute them. We also integrated key and sensor to do QA, right? So we did sort of all the things there, right, for a scan and plan type application. So when that was over, right, we got sort of more requests like, hey, let's kind of port this and let's do scan and plan for maybe aerospace parts, right? And so we launched the A5 program. That was a big collaboration between us, AFRL, and Boeing, right, to try to do a scan and plan for aerospace applications. So we took a lot of that same capability and we started tailoring it for aerospace applications. And we finished that project and sort of got other requests to do scan and plan for different types of applications. And so over time we sort of evolved the scan and plan technology. But after we had finished these, we kind of asked ourselves, like why does it feel like we're sort of reinventing the wheel, right? We made scan and plan in Godel, and then we kind of did it again in a slightly better but different way for A5, and then we did it again in a slightly better but different way for scan and plan workshop. Why wasn't Godel sort of the killer app? And I think our takeaway was not that we did anything wrong. I think we did a great job in all those projects, but really the requirements were just slightly different, and there wasn't really one killer app that could fit all of these different applications, even though we were kind of doing the same thing. And so I think implicitly what we had actually been doing was kind of taking the really good modules and or good features of Godel and of A5 and of Scan and Plan Workshop and kind of distilling them into these sort of reusable blocks, right? And so instead of focusing on this killer app, we're really focusing a lot more on modularity, being able to take these different pieces and build up Scan and Plan type applications and be able to do that in a lot faster way, in a lot more robust way, in a lot more reliable way. And so that's kind of the vision that I see for sort of the tech development for ROS Industrial Consortium is, yes, we'll continue to make cool applications that kind of tie all these pieces together in kind of the scan and plan way. But I think our effort really should be on trying to make these tools much more modular and much more reusable for all of us. That way, we have these reliable tools and we can build up applications easily, but we don't really have to constrain ourselves to like living in this one scan and plan sort of environment. So that's what I kind of want to focus on today is how are we approaching this vision? What sort of work have we been doing in the past couple of years and this past year towards making sort of this toolbox of intuitive and more useful like robotics modules that we can build into these applications. Yeah, so even at the application level, right, we kind of understand scan and plan to be a lot of different modules, right? So when we created Godel, it was kind of this big monolithic thing, right, that had toolpath planning and mesh reconstruction and motion planning pretty deeply sort of embedded inside of it. And I think as we've progressed through these scan and plan applications, we've actually started pulling those things out and making these modules even for just high-level capabilities, right? And so scan and plan now sort of to us means, hey, we've got pieces for sensing, we have pieces for toolpath generation, for motion execution and motion planning, and we have different modules for GUIs and applications. So the scan and plan piece that used to be huge is now getting a lot smaller, and we're kind of farming out capabilities to these various repos that we have since developed that are a little bit more focused on the actual piece of the scan and plan application that they're doing. That's made it a lot easier for us to kind of redeploy them in different ways to do kind of the same thing, but a different flavor and be a little bit more specific to applications or industries with these different types of tools, right? And so for us, again, that provides better flexibility, better reusability for us and for you guys as well if you're trying to take these tools and build up things that are really specific to the types of work that you're trying to do. And in addition to that, right, we try to make these modules a little bit more cohesive, right? So they're not monolithic. They don't try to address everything. Each one of the pieces sort of focuses on its own thing and can be really good and really clear about how it addresses these different. And so I think we've kind of used this little cycle here that I've illustrated on the right? We go through this big development process, we create something, and then we got to figure out what pieces did we do well, how can we sort of reorganize this and distill it into, you know, the actual sort of core pieces that it's trying to do. And so there's some distillation process after we finish these projects to say, hey, cool, let's take these different pieces, and this is going to belong to this repo now, and this is going to belong to some other repo. And then try to do some sort of refactoring every once in a while to say, okay, hey, we've done a lot of work. If we made these slight tweaks, you know, we could actually sort of push this code back and have it address other things a little bit more generally. So that's kind of the approach that we've been taking in terms of developing some of these tools that you see in the ROS Industrial GitHub organization. Develop them, try to distill it, and then refactor and kind of iterate on that process as we're making different types of applications. So at the repo level, I kind of want to talk about how we've actually been doing this on a couple of the really relevant repos for Scan and Plan. So the first one I want to talk about is actually like the Scan and Plan Workshop repo and Blending M5 project itself, right? And so this is kind of the application, our latest iteration of the Scan and Plan application, right? And so we originally sort of put this iteration together for a workshop at ROS-Con, I think in 2021, right? And we've sort of been building that up and refleshing it out. And so I think one of the biggest changes that we've made was kind of revising the way that we architected the whole system, right? And so if we go back a slide, we've tried to architect it a little bit more sort of like this, right? Where all these different capabilities are sort of hidden behind Scan and Plan specific services. So we're able to kind of swap, like ROS services, so we're able to swap out the backends and modify them slightly and make it a little bit easier. And sort of the Scan and Plan application piece itself is a little bit small, right? It's just kind of coordinating the workflow, but not necessarily doing all of the work. And so that's been really important for us to be able to make this application a little bit easier, a little bit more digestible, and a little bit more modular. So that's been a really big change that's been helpful for us. But even with that change going into this Blending Milestone 5 project, we kind of asked ourselves, is there a way that we can change Scan and Plan to make that workflow even a little bit more reusable, a little bit richer, a little bit more customizable, right? Our first iteration kind of just had this 5,000 or 6,000 line case statement that had a really static workflow. It was like, you're going to scan, then you're going to make a tool path, and then you're going to do motion planning, and then you're going to execute it, and then you're going to be done. But for this Blending Milestone 5 project, right, we need to integrate with different types of hardware that are Foundry specific. We need to do operations, you know, at the Foundry level, like maybe trying to repeat motion plans and trajectories some number of times, and maybe switching out media for grinding and various things like that. So we really asked ourselves, is there a way that we can take this and make it a lot better, and a lot more customizable? And so we considered a few options, but we ended up settling on using a behavior tree to sort of define how the workflow goes together for doing Scan and Plan. And I think this has really been a huge game changer in the way that we're able to sort of redeploy the Scan and Plan application. So instead of having our sort of fixed state machine, we took all those different tasks that we were doing and we turned them into these behavior tree nodes, so sort of just tasks that can be done. And this behavior tree library gives us the ability here to kind of specify out in a graphical way, how do you go through these different steps? What sort of connections do you make? How do you share data from one step as the output of one step to the input of another step? And so from that, we've kind of refactored this whole Scan and Plan workflow into a handful of custom nodes and behavior trees. We're able to sort of totally replicate the behavior that we had originally. But what we've also bought ourselves is the ability to kind of scrap this whole workflow and kind of rearrange and make something totally new that still uses the same pieces, but maybe does things in a different order. And so for this Blending Milestone 5 project, that's really been huge for us because to be able to customize Scan and Plan workflow for this Foundry application, we really only had to write about 150 lines of code and make a couple of new behavior tree things in this graphical GUI interface, and we have a completely different workflow that's a lot more customized to the Foundry application. And so that's really been sort of a huge insight for us, is that, if we put ourselves in a framework that lets us sort of define what we want to do as little modules and nodes, and we give ourselves the ability to kind of reorganize those easily, then we can really save ourselves a lot of writing of code to be able to make things that are sort of brand new and very specific to different applications, right? And so we can kind of take these, tailor it to a Foundry or tailor it to an aerospace application. That's been really great. So after we sort of finished this, I was kind of reflecting back on my experience sort of porting the scan and plan application to behavior tree, and I thought the experience was really great, and I was kind of trying to figure out like why I was so happy about how this turned out, right? And so I think I kind of thought about it in a couple different ways. So my interaction with the behavior tree was nice because I was able to kind of go out and look at the repo, and it was very focused, it was very clear and cohesive. So I didn't really have to ask too many questions. I could kind of read, and it was like, oh yeah, I get it. I understand what you're trying to do. They had decent documentation, right? Some examples. It wasn't great, it wasn't perfect, but there was enough stuff out there where it's like, okay, the idea is clear. You showed me how to use it. Now I can go myself and sort of build something easily and customize it, right? Like the killer app was not behavior tree, but behavior tree allowed me to go make this really cool application that we can deploy easily. And so that's sort of what I want y'all's experience to be with the tools that we make at ROS Industrial, right? Like I want these different tools modules to be really cohesive and coherent, where you can go out to the repo, you can read a little bit about them and say, okay, I get it. Like I understand what this piece is supposed to do, and I see the pieces that are there, and I can understand how I can take those pieces and sort of deploy them into this application that I'm trying to build for my own specific use cases. And so I've had, behavior tree is not the only repository or tool that I've had this nice experience with, right? Like Open3D and Drake and ROS-I control to some extent all were kind of the same for me, where it's like, oh, this is really nice and organized well. But that's sort of the vision that I have for our tools going forward, is trying to make them a little bit more coherent and cohesive, adding some documentation to where it's easy to look at them and understand how they work and how you can take them and build something out of them without too much effort. So kind of delving a little bit more deep into those, I wanted to talk about a couple of repos that we've been working on recently that are part of the scan and plan ecosystem, where we've been trying to sort of apply that vision. And so one of those is Tesseract. So if you guys are familiar with that, that's an alternative to Move It for motion planning. So we put that together to be something that sort of addresses maybe industrial motion planning, motion planning for industrial use cases a little bit more directly. And so as a part of that whole design, we've tried to make sort of the interfaces for these core capabilities a little bit more accessible and a little bit cleaner, so we can sort of use various pieces out of that and not necessarily only have to use Tesseract for motion planning. For example, we should be able to use Tesseract to do collision checking for things that maybe aren't necessarily motion planning. We should be able to do IK. We should be able to do some form of like environment visualization. And so I think we've done a lot of work there trying to make those interfaces a little bit more cohesive and easier to sort of grasp and create and build stuff out of. But I think one of the more sort of important changes that we've made to Tesseract in terms of usability is creating these planning pipelines. So motion planning, sort of maybe back in the day when we were working on Godel, sort of just meant you choose one planner, you give it a series of waypoints, and you get this trajectory out. And if things failed, that was sort of it. There wasn't really a lot of steps. There weren't a lot of pieces inside of it. You kind of chose your planner, and that was all you had. But what we've been doing recently is trying to take all these different pieces that we think about for motion planning, like checking waypoints for validity, making sure that they're reachable, doing things like time parameterization, doing things like discrete contact check, taking all those pieces and breaking them out into modules in sort of a similar way to behavior tree, allowing us to take those pieces and build up pipelines for planning. And so this has really been a big game changer for us in terms of reliability for motion plans we've been able to create with Tesseract, right? So we've been able to build out these really custom motion planning pipelines, especially for raster type surface coverage plans that say, hey, at first I want you to try this planner, and if it succeeds, that's great. I'm going to smooth it with some other planner, and then I'm going to do these checks and time parameterization. That's good. But we can also do things when the planners fail. You say, hey, if this planner fails, let's try this other planner with this configuration. If that fails, maybe we try a third configuration. And so what that's allowed us to do is really customize and really tailor these motion planning solutions for an application. So these are some examples up here of our project that we've been working on internally, where we've really kind of flushed out a really big planning pipeline, and kind of allowed us to take a really hard and challenging problem that was maybe not necessarily feasible if we just used one planner, and made that problem feasible, through being able to sort of handle errors and make things a little bit more robust. And so in addition to that, right, we've got all these modules. We have a lot of default capabilities, but these modules are also plugins. And so sort of end users like yourselves don't necessarily have to contribute back to Tesseract to be able to provide these plugins. You can kind of write your own code that does things that's specific to you, and Tesseract can find these plugins, load them, and use them without you necessarily having to share them. So I think that's sort of a nice piece as well, is being able to embed your custom code into Tesseract without a ton of effort. And so one other important piece, too, in terms of usability for Tesseract that we've been working on a lot is the visualization of what happens to your trajectory after each of these steps in the planning pipeline, right? And so a lot of times when you're tuning these pipelines, your motion plan fails, and you wonder why, and you don't really get that much feedback back. But what we've been doing is after each step, basically saving the trajectory, whether it started or failed, and being able to visualize that in RViz using sort of the Tesseract workbench. And so it's been really nice to say, hey, I tried Descartes, it said it failed, let me see what the final result was, and I can maybe see, oh, okay, it was asking it to do something possible. So this has also been a really, really big improvement for us that we're trying to kind of finalize and push out and integrate into a lot of our applications. Hopefully that'll make it much easier for those of you who are trying to use Tesseract to figure out, hey, how do I get these kind of complex motion planners to behave the way that I want? So another repo that we've been working on quite a bit is Nether for toolpath planning. So this is, again, sort of another module of scan and plan that we've tried to sort of distill and make a little bit more cohesive. And some of the things that we've been doing there, right, is sort of refactoring this whole idea, trying to make some of those kind of clear abstract interfaces for, like, what is a toolpath planner? What does it take in, and what does it give out? Right, and so I think we've done a pretty good job sort of refactoring that and developing these interfaces in a way that addresses, like, a lot of the use cases that we've seen for toolpath planning, as well as being able to support a lot of different implementations of them. And so part of that, right, is we make these interfaces, but we've also made a lot of the capabilities that sort of sit behind those, right? And so in terms of things like mesh modification, right, we want to give a mesh and get a toolpath back, but maybe we want to give a mesh and sort of do some stuff to it before we try to toolpath plan on top of it. And so we've made quite a few mesh modifiers for things like trying to fit primitives to a mesh, like trying to fit a plane or a sphere to a mesh and then generating toolpaths on that fitted primitive instead. Doing things like region of interest selection too for the mesh modifications, so not generating toolpaths on an entire mesh, but on some regions. We've done a lot of work sort of porting our toolpath planners into this new framework, and then doing things like toolpath modification after the fact, right? Adding approaches and departures for things like grinders or sanders or painters, right? Paint tools. Doing things like smoothing and maybe reorganization of the rasters to give it sort of behavior. So these are things that we had sort of baked pretty deeply into applications like Godel and A5, and so after we developed those are sort of the things that we distilled out and said, hey, these actually don't belong in the application. They sort of belong as pieces that you can add on top of your toolpath. So we've been doing quite a bit of work there, as well as making sort of nice GUI interfaces for being able to kind of configure this whole pipeline about how do I modify a mesh, create a toolpath, and then modify the toolpath to kind of get out my input to the motion planner that I really want. So that's what we're showing here on the right. It's like, hey, we've got a lot of these capabilities. Click on the GUI, you can kind of see them all, right? We need to do obviously a little bit better work on sort of documentation and telling you what they actually do, right? But we're taking steps in that direction to make this whole thing a little bit more customizable and easier to. So another repo, I think maybe the final one I want to touch on is calibration, right? So this is kind of the linchpin in doing any sort of perception-driven application, right, is calibrating your camera to your robot. So we've done a lot of work here as well, sort of reorganizing some of our old repos into a new structure that makes a little bit more sense, that's a little bit clearer, a little bit more modular as well. And so we've done a lot of work sort of providing utilities, for doing the calibrations, but also for sort of doing the data processing to detect targets, and doing a lot of work on like validating the calibration, giving you some actual quantitative data about how good it is and whether or not you should trust it. So we've provided a lot of utilities for doing that. We're also working on sort of integrating that into a GUI, right, where you can sort of upload your calibration artifacts, like your pictures and your poses, be able to run the calibration, and then have this GUI sort of run through those checks and give you some sort of feedback about, hey, it works, this was your error, you know, it's pretty good, you know, whatever. Give me a little bit more feedback about whether or not you should trust your calibration. We've also added in a lot of hooks for customizability as well in terms of trying to support different calibration targets and different types of sensors and different types of sensor data, right, like 2D images or 3D point clouds or laser line scans and things like that. Also working on some example like data collection pipelines as well, saying, hey, if you wanted to collect data, here's maybe a structure that you could use in an application that would collect this data for this particular type of sensor. That's just sort of an example of how you start using this calibration library. Yeah, Matt touched on it a little bit too, right? So we have all these modules, and we have this big scan and plan application, but you know, it still at the moment sort of requires a lot of writing and touching of code. And so, yeah, we've done quite a bit of work developing this SwRI application, which is essentially trying to wrap a lot of these ROS industrial tool modules into a CAD-based environment to be able to kind of experiment around with maybe how do we set up these applications, how do we tune motion planning for these applications. And so this has really been a big help to us at SwRI internally, right, because we spend a lot of time trying to figure out how do you make these systems do complex motions for complex tasks. And that iteration cycle is just really long when you have to launch ROS, test something, bring it all down, change parameters, rebuild, test again, right? If we can sort of do that embedded in a GUI software, where we can really reduce that iteration cycle a lot. So that's been really helpful for us for visualizing our setup, checking IK, and then also trying to tune these motion planners that have a lot of parameters that we may or may not really understand. And so definitely recommend checking this out. Come talk to me or Matt or Jeremy anytime if you're curious about SwRI and what the capabilities are and what some potential use cases. Check that out as well. So in addition to sort of making modularity a little bit better at the repository level, last thing I wanted to touch on was trying to be a little bit more modular for deployments. So this is something we've been focusing on quite a bit for the Blending Milestone 5 project as well, as how do we make deployments a little bit easier and a little bit more repeatable for these scan and plan type applications. And so in these repositories, we're trying to target builds on different platforms, right? So Tesseract and a few other ROS-I tools are building both on Windows and on Ubuntu, which is nice. And so we're trying to support that really more across the board, supporting multiple distros, I think like Foxy and Humble and 2204 and 2004 for Ubuntu as well, to kind of broaden the tent in terms of usability of these tools. And we tried to do some common CI practices across all of these as well, just to say, hey, this actually builds when you pull it down and you try it if you follow our instructions, right? Making sure that we have some consistent level of sort of repeatability for these different types of tools. So containerization is another piece for deployment that we've been focusing a lot on. So part of our CI process for these repos is to build a container that you can actually pull down and use to address or to sort of build an application off of. And so we've actually done that for the Blending Milestone 5 project, and that's sort of this graphic that I have over on the side here. Right, so we build Docker images for sort of all the layers of Tesseract. We build it for Scan and Plan Workshop and all the sort of actual implementations of Scan and Plan Workshop. So the demo that you guys are going to see later today in our lab that's running Scan and Plan, basically running one of these Docker images that's built off this whole stack. What we deployed at Fisher Castile for Blending Milestone 5 is also something that came directly off the stack. And so this has been really, really helpful for us to say, hey, here's a repeatable actual instance that you could download. It's agnostic to user. It's not built specifically for some specific computer. And then we also have sort of the configuration there to launch that container to be able to like access devices like sensors and robots and sort of configure networks correctly. So if you wanted to sort of replicate Scan and Plan Workshop, you could potentially download this if you had all the same hardware. But it's also a really good reference point for if you wanted to do sort of a container-based deployment for something like Scan and Plan, you could at least go look at those things and have some reference about how we did that. So this has been really, really beneficial for us as well in terms of deployment. Yeah, so to kind of wrap up here, some takeaways I had from this, thinking back about all these different iterations of Scan and Plan that we've gone through is like maybe we really haven't hit that killer app necessarily. We made some really great applications, But I think maybe what we've done is tried to make some killer building blocks, right? Where things that you can take and build into your application a lot easier. And so that's really what I want to focus on is, yes, let's continue making cool applications that bring all these things together, but let's really focus on making sort of the independent modules that build that up really, really nice and really deployable, right? Asterisk being, there still is a lot of work to be done, right? If you've gone out and looked at any of these repos, the documentation is generally not super great. You know, maybe we haven't done our best job at making those interfaces and everything clear and cohesive, right? So I think those are the kind of things that we want to focus on sort of going forward to make those tools better. But contributions obviously are always welcome. So if you guys have sort of code contributions you want to make, that's great. But if you also have feedback about, you know, hey, I saw you guys refactor this, but it doesn't really make sense, or I'm trying to take this tool and I want to deploy it in this application, I don't understand how it fits. Please let us know. We're happy to sort of sit down with you guys and try to figure out, hey, is there a way that we can adjust what we have to address your use case, right? And so that's part of that iteration cycle. Yeah, with that, thanks for the time. Happy to answer any questions that you guys might have.
Thanks, Michael. Questions for Michael?
Crystal clear, all right.
Crystal. Oh, we have one, Bharat. Spirit.
Yeah, so for the online audience, the question was the behavior tree library something that we built ourselves or something that we got elsewhere? It was something that we got elsewhere. So there's a library, a repository online called Behavior Tree CPP. So that's maybe all the rage in the last year, 18 months, but that's what we use for the behavior tree. And then there's a sort of an accompanying tool called the Groot that is the sort of graphical editor for the behavior tree.
Thanks, Bharat. Anyone else? Yeah, chat on the all quiet or? Oh, thanks, Paul. I'm monitoring the chat. I guess while Paul glances at that, a couple logistical things. I omitted the break in the agenda, so after Joe Shornack's talk, there'll be a 15-minute break, so FYI. Yes? There's a question. Oh, there is a question. How much modification to FreeCAD itself was required to create the SwRI interface? Was the plugin/workbench system flexible enough, or did it require deeper modification?
Yeah, so SwRI is a workbench plugin for FreeCAD. So we did not do any modification to FreeCAD itself. We were just building something that plugs into FreeCAD. But in terms of, the amount of work that it takes to do that is not trivial. It was a lot of research into how does FreeCAD sort of work and how do we embed these different sort of motion planning and toolpath generation tools. So, it's been a bit of a journey, but yeah, no modifications to FreeCAD.
Awesome. Thanks, Michael. All right. So I do have one other logistical thing. Oh, we have another question. Omar.
Regarding the Caterpillar, we want to build our own workbench. That's something that we can kind of use SwRI and kind of build our own workbenches.
Yeah, so at the moment, we are not planning on sharing the code for SwRI, so I think that probably would not work necessarily. I don't know, we could probably talk and figure something out, but at the moment, I think we're not necessarily planning on people having to build and modify and look at the source code for SwRI. Could change it.